the opcode right now is 0000, and A right now is 0000, since all these switches are down. And right now it's showing that the output is 1111, which is correct because the opcode is in inversion. You can see that the carry out bit is turned on, which doesn't matter for inversion. The 0 bit is off because this is not 0, and this is overflow, which is again irrelevant for inversion. And if I turn this bit on, it will invert. As you can see, this is working correctly. And if all of them are on, you can see that that's overflow, but now this will turn on 0, which actually matters because now the output is 0 and it's showing 0. Alright, and now opcode 1 is an arithmetic shift left by B, by 2. B is hard-coded to be 2. And if I have 2 here, it shifts it that way twice. So the last bit would turn on if I have 2 here. So you can see that this is 0, 2, 0, 1, 2, 3. This is 0, 1, 2, 3. So what I had at 1 went to 2. So this is an arithmetic left shift. If I had 1, it will turn on there. If I had 2 more, it would turn on there. And of course the carry-in doesn't matter. And that's left shifting. And operation 2 is a logical left shift, which is the exact same thing, and it will do the exact same thing. For example, if I had this value right here, which is 1, shifting by 2, it would appear in the it's in the 0th place, and it will appear in the 0, 1, 2, the second position. And then if I had 2 bits, it again does those 2 bits as well. At 3 bits, doesn't matter, it's shifted outside. If I had just this bit, which is this bit or this bit, so it will shift outside the range because the shifting is by 2. And that's an arithmetic shift. Now 3 is an arithmetic shift right. So I have shift right by 2, and if I have the if I had the sign bit, which is this bit, 1, and if I shifted everything by 2, then the shifting would be like that. If I had this on, it would turn on the last bit because, well, I shifted a 1000. Arithmetically, it would copy that 1 all the way through to both those places because it was shifting this way. And now if I turn this on, it just means that I was shifting at 1100, which will turn everything 1 because I'm shifting by 2, and it will refill those last 2 spots with both 1s. Alright, and that's arithmetic shift right. Now a logical shift right, which is opcode 4. So it would be 4. And you can see that all those 1s suddenly disappeared, and now we're just left with the 2, which is just a straight up shift right by 2. And if I had just a single bit and it doesn't do anything other than shift by 2 and no copy of 1s, this won't do anything because it just goes outside the input range because you're shifting by 2 and you have a 2, so this will go right there and right there, but that is not in the range of the input. So there we go. That's shifting right. Logically, subtraction is next. That is just 1 more than this. The opcode just increases by 1 every time. And then it's B from A, so I'm subtracting 0 from 2 and I'm getting a -2. You can see that this is -2 because it's represented in 2's complement. And if you flip all these bits, so that becomes 0, 0, 0, 1. And if you add 1 more to it, and of course that's 2, so this is -2, and that's with all output 0. Now if I put a 1 in there, now it becomes -1 because I have 1 more, and then if you do the conversion from 2's complement to regular numbers, 0, 0, 0, 0, and add a 1, which is indeed 1. Now if I have a 2 in there, it's 2 minus 2, which is 0. That works. Now to test out the overflow, which is a feature that's key, which is this light right here, I'm going to subtract from 2, or subtract a 8 from 2. Or no, sorry, negative 2, 2 from negative 2, 2 from negative 8, which is going to be just by 2's complement. 8 is the highest bit. 8 is like that. So this is 8 from 2's complement, and you can see that there is overflow, which is this light right here. See, this light right there, it says overflow because I'm subtracting I'm doing a negative 8 minus a 2, a positive 2, and that's more than what the negative 8 is maximum, the largest negative number that 4 bits can handle, and when you're representing both positive and negative bits. So this is overflow. Is an example of it. Next help code, addition with CN. Okay, so I'm adding to the 2 is already in B, and I'm adding 0 to 2, and that's a 2. And if I add a 2 to a 2, it becomes a 4. If I add a 4 to a 2, it becomes a 6. And 2 to a 6, and then that's an 8. And then plus another 2, that's it's a 10. And then that's also beyond what negative 7 is the maximum positive number you can handle with only 4 bits in 2's complement. So overflow is on. And if I were to just do 6 plus 1, 7, or 5 plus 2, which is 7, and then that's 7 displayed right there. The next one, it's full-on addition with carry-in. And so if I flip the carry-in bit, I'm adding 1 more, and that is indeed the right answer, because if I had 1 more, I wouldn't be able to do it. But if I subtract 1 from here, I would get the same result. See, the carry-in is adding 1 more. In fact, we just do that simply. It's going to be C. See, so 2 plus 1 is indeed 3. And the next one, add. Yeah, just straight up addition without the C in. This doesn't matter. See, it doesn't affect it anymore. And again, it adds, as you can see. The overflow works properly. The carry-in also works properly. It just displays the carry-in. I mean, see, there's a 2. I'm going to add a 2 to it, then I add a 4 to it, and then I'm going to add a 6 to it. And then you can see that there's also a carry-out, because I was pushing that 1 all the way to the end, and eventually there was a carry-out. So